Hello friends, I am Professor Rajendra Koranne from my YouTube channel Teach Easy. In this fourth video of Applied Mechanics, I am going to present some MCQs on the topic of resolution and composition of forces of Applied Mechanics. So without wasting the time, let us start. Question number 1. The process of splitting a single force into number of parts is known as A. Composition, B. Resolution, C. Addition, and D. None of the above. When we divide a single force into number of parts, it is known as resolution, and hence the correct answer is B. Resolution. Question number 2. For the force in first quadrant, the horizontal component is dash 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 and the vertical component is dash dash dash. A. Positive, negative. B. Negative, positive. C. Positive, positive. And D. Negative, negative. We know that whenever the point lies in the first quadrant, its x and y coordinates both are positive. Similarly, when the force lies in first quadrant, both components are positive. Hence the correct answer is C. Positive, positive. Question number 3. If the force is in between north and west, the horizontal component is dash 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 and the vertical component is dash dash dash. A. Positive, negative. B. Negative, positive. C. Positive, positive. And D. Negative, negative. Now here the force is acting between north and west. North is vertically upward, west is to the left, means the force is acting in second quadrant. In second quadrant, x component or horizontal component is negative and vertical component is positive. Hence the correct answer is B. Negative, positive. Question number 4. If the horizontal and vertical component of a force are negative, then that force is acting in between A. South and west, B. South and east, C. North and west, and D. North and east. Now here the sign of the components are given and you have to identify that in which quadrant the force is acting. Now here both horizontal and vertical components are given negative, means the force is acting in between, means third quadrant, and third quadrant is in between south and west. Hence the correct answer is A. South and west. Question number 5. A force of 100 Newton is acting along 30 degrees west of south. Its horizontal component will be A. minus 50 Newton, B. plus 86.6 Newton, C. minus 86.6 Newton, and D. plus 50 Newton. Now this 100 Newton force is acting in fourth quadrant. 30 degrees west of south means from south to west, means the angle is made with negative y-axis. Hence his horizontal component will be in fourth quadrant, so it is positive. So plus 100 sine 30 and it will be plus 50. Hence the correct answer is D. plus 50. Question number 6. A force of 100 Newton is acting along 30 degrees west of south. Its vertical component will be A. minus 50 Newton, B. plus 86.6 Newton, C. minus 86.6 Newton, and D. plus 50 Newton. Now this is the same force in the previous question, only now it is asked vertical component. The force is in fourth quadrant, so vertical component will be negative, and as the angle is made with vertical, so it will be minus 100 cos 30, which will come out to be minus 86.6 Newton. Hence the correct answer is C. minus 86.6 Newton. Question number 7. A force of 5 kilonewton is acting due north. Its horizontal component is dash 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 and vertical component is dash dash dash. A. plus 5 Newton, 0 Newton. B. 0 Newton plus 5 Newton. C. 0 Newton minus 5 Newton. And D. minus 5 Newton, 0 Newton. Now here the force is acting due north, means it is acting vertically upward, means the force is vertical, so its horizontal component will be 0 and vertical component will be that force itself. Hence the horizontal component will be 0 and vertical component will be plus 5. Hence the correct answer is B, 0 Newton plus 5 Newton. Question number 8. A force of 5 kilonewton is acting due west. Its horizontal component is dash 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 and vertical component is dash dash dash. A, plus 5 Newton, 0 Newton. B, 0 Newton plus 5 Newton. C, 0 Newton minus 5 Newton. And D, minus 5 Newton, 0 Newton. Now, just like previous one, here the force is given horizontal. It is due west, means towards left, means its horizontal, means its horizontal component will be minus that force and vertical component will be 0. Hence the correct answer will be minus 5 Newton and 0 Newton. That is D, minus 5 Newton, 0 Newton. Question number 9. A force F is inclined at theta degrees with the horizontal. If its orthogonal components are equal in magnitude, then theta in degrees will be dash dash dash. A, 30, B, 60, C, 45 and D, 90. Now let us try to understand what is given in this question. A force is given which is inclined at theta with the horizontal. Now as the force is inclined with horizontal, its horizontal component will be F cos theta and vertical component will be F sin theta. Now what is given? Their magnitudes are equal. So F cos theta is equal to F sin theta. So sin theta and cos theta are equal. So theta you will get as 45 degrees. Hence the correct answer is C, 45. Question number 10. The process of combining the effects of number of forces acting on a body into a single equivalent force is known as A, composition, B, resolution, C, subtraction and D, none of the above. Now when we add up the effect of number of forces acting on a body and convert it into single equivalent force which is known as a resultant, this process is known as composition. Hence the correct answer is A, composition. Question number 11. The two forces P and Q act at and away from a point including an angle of theta between them. If P is equal to 10 kilonewton, Q is equal to 6 kilonewton and theta is equal to 0 degrees, then their resultant will be A, 16 kilonewton, B, 4 kilonewton, C, 14 kilonewton, D, 11.66 kilonewton. Now in this question, P and Q are given, theta is given. You can definitely apply the parallelogram theorem to find out resultant, that is R square is equal to P square plus Q square plus 2PQ cos theta, and then finding out square root, you will get the resultant. Now simply to solve this quickly, when the angle between them is 0 degrees, means they are collinear and acting in the same direction. So their resultant will be nothing but 10 plus 6, that is 16. Hence the correct answer of this question is A, 16. Keep in mind that you can also solve this by substituting the values in the parallelogram formula. Question number 12. Two forces P and Q act at and away from a point including an angle of theta between them. If P is 10, Q is 6 and theta is equal to 60 degrees, then their resultant will be A, 16 kilonewton, B, 4 kilonewton, C, 14 kilonewton and D, 11.16 kilonewton. Now this is the same question, only the value of theta had changed. So you put values of P, Q and theta in the formula. R square is equal to P square plus Q square plus 2PQ cos theta. You will get the value of resultant as 14 kilonewton. Hence the correct answer is C, 14 kilonewton. Question number 13. The two forces P and Q act at and away from a point including an angle of theta between them. If P is 10, Q is 6 and theta is equal to 90 degrees, then their resultant will be A, 16 kilonewton, B 4 kilonewton, C 14 kilonewton, and D 11.16 kilonewton. Again, this is the same problem, only value of theta had changed. So substitute P, Q and theta in the appropriate formula. You will get the resultant as 11.16 kilonewton. Hence the correct answer is D, 11.16 kilonewton. Question number 14. Two forces P and Q act at and away from a point including an angle of theta between them. If P is 10 kilonewton, Q is 6 kilonewton and theta is 120 degrees, then their resultant will be 16, 8.72 kilonewton, 14 kilonewton and 11.16 kilonewton. Again, this is the same question, value of theta had changed, so put correct values of P, Q and theta in the appropriate formula to get the resultant, and you will get the value of resultant as 8.72 kilonewton. Hence the correct answer is B, 8.72 kilonewton. Question number 15. Two forces P and Q act at and away from a point including an angle of theta between them. If P is 10, Q is 6 and theta is 180 degrees, then their resultant will be A, 16 kilonewton, B 4 kilonewton, C 14 kilonewton and D 11.66 kilonewton. Now in this example you will see that angle between them is 180 degrees, means they are collinear and they are acting opposite. So their resultant will be nothing but P minus Q simply. You can get the same answer by substituting the correct values of P, Q and theta in the appropriate formula. Now if resultant, in this case theta is 180 degrees, resultant will be P minus Q, hence it will be 10 minus 6, that is 4 kilonewton, and the correct answer is B, 4 kilonewton. Question number 16. Two forces P each act at and away from a point including an angle of theta between them. Their resultant is P root 2. Then the value of theta in degrees will be A 60, B 120, C 45 and D 90. Now here P is equal to P, Q is equal to P and R is equal to P root 2. Angle theta is given. Substitute all these values of P, Q and R in the formula P square plus Q square plus 2PQ cos theta is equal to R square. You will get the value of theta, and the value of theta you will get will be 90 degrees. Hence the correct answer is D, 90. Question number 17. If the magnitudes of two forces acting at a point and the magnitude of their resultant are equal, then the angle between the two forces will be A 120 degrees, B 60 degrees, C 30 degrees and D 90 degrees. Now here P is equal to Q is equal to R. So substitute in the formula R square is equal to P square plus Q square plus 2PQ cos theta. You will get the value of theta, and the value of theta will be 120 degrees. Hence the correct answer is A, 120 degrees. Question number 18. Two forces P and Q act at a point. If their maximum and minimum resultant is 50 kilonewton and 16 kilonewton respectively, then the magnitude of P and Q will be A 17 kilonewton and 33 kilonewton, B 30 kilonewton and 20 kilonewton, C 33 kilonewton and 17 kilonewton and D none of the above. Now this is not a simple question. See, please try to understand it. P and Q two forces are acting at a point. Their maximum and minimum resultant is given. Now in the previous questions we saw that when value of theta is equal to 0, resultant is maximum, that is P plus Q. When value of theta is 180, resultant is minimum, that is P minus Q. So you have got two equations, P plus Q is equal to 50 and P minus Q is equal to 16. So if you solve these two equations simultaneously for P and Q, you will get the value of P and Q, and value of P will be 33 kilonewton and value of Q will be 17 kilonewton. Hence the correct answer is C, 33 kilonewton and 17 kilonewton. Question number 19. The resultant of two concurrent forces can be determined graphically by drawing A. Triangle of forces, B. Parallelogram of forces, C. Polygon of forces, D. Both A and B above. Now when we want to find out the resultant of two concurrent forces graphically, we can find out either constructing a triangle or constructing a parallelogram. Hence, the answer of this is D. Both A and B above. Question number 20. The resultant of three or more concurrent forces can be determined graphically by drawing A. Triangle of forces, B. Parallelogram of forces, C. Polygon of forces, D. Both A and B above. Now here number of forces are 3 and more, they are concurrent forces, so triangle of forces is not useful, parallelogram of forces is also not useful, but we will have to draw polygon of forces according to law of polygon of forces, and hence the correct answer is C. Polygon of forces. Question number 21. The diagram in which the directions of the forces are drawn and the spaces formed are named according to Bose notation is known as A. Force diagram, B. Space diagram, C. Vector diagram, and D. Polar diagram. Now this is by Bose notation. We know that the diagram in which direction of the force is given and the spaces are named according to Bose notation, that diagram is known as space diagram. Hence the correct answer is B. Space diagram. Question number 22. The diagram in which the forces are represented by vectors with Bose notation according to the law of polygon of forces is known as A. Link polygon, B. Space diagram, C. Vector diagram, and D. Polar diagram. Now the diagram in which the forces are represented as vectors means magnitude as well as directions are given, so it is nothing but a vector diagram. Hence the correct answer is C. Vector diagram. Question number 23. The movement of a force about a point which lies on its line of action is always 0 because A. Magnitude of force is 0, B. The perpendicular distance is 0, C. Both magnitude and perpendicular distance are 0, and C, D. None of the above. Now here when the force acting along a particular line, and if you want to find out the moment of that force about any point on its line of action, definitely its movement will be 0. It is due to the reason that as the force is passing through that point, perpendicular distance is 0. Hence the correct answer is B. Perpendicular distance is 0. Question number 14. The Varignon's theorem of moments is used to determine A. Position of resultant of non-concurrent forces, B. Position of resultant of concurrent forces, C. Magnitude of resultant of non-concurrent forces, D. Magnitude of resultant of concurrent forces. Now we know that in case of non-concurrent forces, additional job is to find out the position of that resultant, which we can find out using Varignon's theorem of moment. Hence, the correct answer of this is A. Position of resultant of non-concurrent forces. Question number 25. Which of the following diagrams are necessary to locate the position of the resultant of non-concurrent forces? A. Vector diagram, B. Polar diagram, C. Funicular polygon, and D. Both B and C above. Now, in case of non-concurrent forces, we know that there is an additional job to find out the position. In analytical method, we do it using Varignon's theorem of moment. In graphical method, this extra job is done constructing two more diagrams, that is polar diagram and funicular polygon. Hence, the correct answer of this question is D. Both B and C above. Question number 26. For a system of forces, the vector diagram is a vertical straight line. It means that the forces are A. Concurrent, B. Parallel to each other, C. Vertical and parallel to each other, and D. Non-concurrent. Now here vector diagram is given and vector diagram is vertical straight line. So it cannot be concurrent forces. Second, it can be parallel forces. But how they are? Parallel forces can be horizontal, can be vertical. So, vertical and parallel to each other, this is the correct option. Hence, the correct answer is C, vertical and parallel to each other. Thank you.